Section 8.3, we'll look at now some examples of the hyperbola, starting with letter A here. X squared over 9 minus y squared over 16 is equal to 1, and we're looking at finding the center, the foci, the vertices, and the slope of the asymptotes. Similar to the ellipse, we just see an x squared and a y squared here, nothing else within those, and that means that 0, 0 is going to be the center of our hyperbola. You're noticing that the x squared is coming first. The x squared is the positive term, and we knew that when x squared was positive, it means that this hyperbola is curving around the x-axis. So we know that our hyperbola is opening in this direction. We know that its center, if I wanted to do a quick little sketch, is at 0, 0. Notice that it doesn't ask me for a sketch, but just like in the ellipse in most questions, I'm going to draw at least a little bit of a sketch to make sure that I know where the problem is centered around and the orientation, if the A value is going up and down or right and left. So it really just helps make things a little more clear if I include a quick little sketch. All right, now that I have my picture, I know which direction it's opening, I know where the center is, we're going to pick out the A and the B, remembering that in our hyperbola up here on the right upper right corner here, we see the A squared value, reminder that that's always underneath our positive term. So by looking at our equation, I know that A is equal to 3, I know that B is equal to 4. And just to make sure that I'm writing everything down, sometimes we don't need all of them, but in this case they're going to ask us for the foci, and we remember that the distance from the center to a focus point is C, so we might as well find that while we're at it. Remember that C is not directly in the equation. The equation just has your A squared and your B squared up here. But to find that, we had the Pythagorean relation, and for that we knew that A squared plus B squared is equal to C squared. So A squared was 9, B squared was 16. That's going to make my C squared value 25, or in other words, C is equal to 5. Now that I have that information, I should be able to list the foci and the vertices. The distance from the center to the focus point is 5. Since I'm moving to the right, that's going to make that coordinate 5, 0. That means when I go to the left to find that coordinate, we're going to be over here at negative 5, 0. Like I said, do you need to draw the picture and do you need to label it over there? You certainly don't, but sometimes it just helps to clarify where those coordinates are. We mentioned in the ellipse, we didn't want to accidentally write 0 plus or minus 5 instead of plus or minus 5, 0. So it just helps to eliminate some of those errors. Distance to the vertices then, remember the A value was the distance to the vertex, and we have 2 of them right there. If we're going 3 to the right and 3 to the left, that's going to put us at plus or minus 3, 0. Remember, you can write the plus or minus. You also can write them out individually like you saw me do over here. Negative 5, 0, positive 5, 0, negative 3, 0, positive 3, 0. Both of those are fine. Finally, for the asymptote slope, remember that our asymptote is going to be going through the center and at an angle over here through the center. And remember that the slopes, one is positive and one is negative, and that it's either A over B or B over A. So we had talked about in the description, if I'm going to find the slope, I remember that slope is rise over run. And again, either A over B or B over A. B was that imaginary point, so we're going to focus on where A is. A is the distance from the center to this vertex right here. So if I'm finding the distance from the center to the vertex, is that distance the rise or the run? In this picture, you can see by where my pen is right now that the A value is the run. So this A value of 3 is the distance we're running. That means the rise is the B value, and that's going to be 4. So the A was the run, that means B is the rise. And remember that the slope, one is positive and one is negative, so you're always going to see a plus or minus in front of that when you write the slope. And that's how you would complete letter A. Letter B, when we look at the center, I would ask you to take just a second to think in your head, where is the center of this hyperbola? When I ask people to think about where that center is in class, I would say we're about 50-50 for getting that answer right, because what we want you to notice, look at this, the y value actually comes first, right? And then the x value. So your center is actually going to be at -2, +3. It's really tempting to switch those around and just say 3, -2, because we're used to looking at them in the correct order. But in the hyperbola, if the y squared is positive, now that's going to change where your center is. And not only does it change your center from 0, 0, but we also have to watch which one is x and which one is y. Now, as I mentioned every single time, we're going to do it again. We're going to draw a quick sketch of this, and with a positive y squared value, we're going to make a hyperbola that's opening up and down, curving around in that y-axis direction. Now, I don't have a slide about what happens when we change the center, but I think we can do it without looking at those formal definitions. And so we'll just label and use what we know about the distance of A to the vertex and the distance of C to the focus point, and I think we'll be able to figure it out from there. So let's look at our equation to start. We've got the 4 underneath the first term, the 36 underneath the second term. Remember that A is always underneath the positive value, so that means that A is going to be 2. That means my B value is going to be 6. And we'll find the C value, again, A squared plus B squared equals C squared this time around. A squared is 4, B squared is 36. That makes C squared 40. Now for C, it doesn't matter how you write it. If you want to write the square root of 40, that's fine. If you want to write it as a decimal, that's also fine. If you want to say, well, the square root of 40 is really square root of 4 times 10, so maybe I want to write that as 2 times the square root of 10, that's also fine. So it doesn't matter which format that you leave it in. And as kind of a little trick that some of you might like, when you're finding the value of C, since you're doing A squared plus B squared, we know that those are just the denominator values, right? So A squared is 4, B squared is 36. Just by looking at it, I know that the C squared value is 40, and therefore C is the square root of 40. All right, so let's plot those points. If we start at -2, 3, the distance to the foci are listed first here on our list, so we might as well find those as well. So that's a distance of C, but we're going up, right? We're going up. So remember that that's going to leave your x value exactly the same. My x value is going to stay at -2, but my y value, to that, I'm going up a distance of the square root of 40, or 2 square root of 10. So I start at 3, and now I'm going to add 2 square root of 10. And when I find the other focus point, again, the x value stays the same. I'm starting at 3, and now I'm going down to square root of 10. So my foci I'm going to list as -2, and then I can say 3 plus or minus 2 square root of 10. My vertex points are going to be done in a similar fashion here. The A value is the distance from the center to that vertex point. A is 2, so now I'm going up 2 and down 2. Again, not changing the x value at all, so going up 2 puts you at 5. Going down 2 on that y value puts you at 1. And again, I'm just drawing them on the graph here. It doesn't say that you have to in your homework. It doesn't say that you have to, but oftentimes it just helps us to visualize that and to help get the right final answer. So we have -2, 5, -2, 1. And finally, our asymptote slope. Again, when we're talking about that slope, thinking of rise over run, I know that it's either A over B or B over A. Which one is it? So think about, what did the A do? Was the A rising or running? Looks like the A is my rise. That's going to put B as my run. So my A value was 2. My B value is 6. And remember, we're going to have a plus or minus in front of there. So plus or minus 2. 6 certainly could simplify that to be plus or minus 1/3 for the slope of those asymptotes. Now, if they asked you to write the equation of that asymptote line, it is going to be a little bit different because this doesn't have a y-intercept of 0, 0. And so we would have to be careful about writing the equation. It's not just y equals 1/3 x because we're not going through 0, 0. But again, we're just going to ask you about the slope, not the equation. Next example, similar to what you saw in the ellipse, sometimes they give it to us in a form in which we don't really recognize what's the A value, what's the B value, where's the center, and we might need to do some completing of the square in order to solve that. So let's complete the square on this example. Same as we saw for the ellipse and the circle, we're going to separate the x's. We're going to group those together, 4x squared plus 24x. We're going to group the y's, that's minus y squared plus 4y. And those constants, we don't need those right away. We're just going to go ahead and move those over to the right-hand side. Now, in completing the square, we want a positive 1 as our leading coefficient. So in my first grouping of the x, I'm going to factor out a 4. That's going to leave me with x squared plus 6x, as you've seen me do so far. We're going to leave a little space because I know I'm going to need to add something there. For the y's, hey, a common error is for people to say, I don't need to factor anything out of there. Looks like I already see a 1 in front of the y squared. But remember that we want a positive 1 leading coefficient. So even though it seems like we don't need to factor anything out, I'm going to take out a negative 1 because I want a positive y squared inside those parentheses. Now when I do that, notice that that changes the 4y to be a negative 4y, and likewise I'm going to leave a space at the end, equals negative 28. Now I will go through and complete the square. So half of this linear term gives me that 3x plus 3 squared. Square that value is going to be a plus 9, but remember that means that I'm really adding 36 over here to the right-hand side. Y values, we're going to do the same thing. Half of that value is 2. Square it means I'm adding 4, but I'm really subtracting 4 because I need to distribute that through to take everything into account. And that makes the right-hand side equal to 4. Still want to get this into our standard form of the ellipse, or standard form of the hyperbola, rather, which is going to need to be set equal to 1, just like the ellipse was. And so we're going to divide every single term by a 4. And when I do that, I have x plus 3 squared minus y minus 2 squared over 4, and that's going to be set equal to 1. Now you notice that the x plus 3 squared doesn't have a value underneath it. So what does that mean about your value of a squared? Well, of course that means there's a 1 down there. So now I can tell that my a value is equal to 1, my b value is equal to 2, and if we went through the a squared plus b squared equals c squared, a squared plus b squared is going to give me 5, so c is going to be the square root of 5. At this point, you can pause the video, go ahead and sketch what this hyperbola is going to look like and see if you can determine the center, foci, vertices, and asymptote slope. All right, in purple up in the right-hand corner, you can see the final answers for the center, foci, vertices, and asymptote slope. In the ellipse, we talked about the eccentricity of the ellipse, helping to tell us the overall shape of that ellipse. The same thing happens with our hyperbola. In the hyperbola, the ellipse is still c over a, just as it was in the ellipse. And now that hyperbola value, remembering that c is always going to be bigger than a. That was the distance to the focus point, and the focus was always farther from the center than what the a value would be. So if we have an ellipse whose eccentricity is not close to 1, that's not going to curve very much. It's going to be a very gradual curve, as you see on the bottom here. As that eccentricity gets closer to 1, now you're going to have a much steeper curve, much more pronounced curve on the side. And again, it's always going to be greater than 1 as we do our calculations there. Another example for us to look at, write the equation of the hyperbola that has a center at -2, -4, and a focus at 6, -4. Also eccentricity of 4/3. So as we figure this one out, well, gosh, that's not really the same as the other examples we have, but they gave us a couple coordinates. We saw that in our other sections, and usually we decided, let's kind of sketch where those are, and that might help us to determine what's happening here. So if we're going to do a quick little sketch here, we're going to say we have a center at -2, -4. So here's my center at -2, -4. Make sure we keep track of C for center, not as C for the distance to the focus. So as we've done in the other questions, we're going to want to at least plot out a few points to sketch a picture. So I'm going to draw a quick little XY axis. We're going to plot our center at -2, -4. And again, C for center, not C as in the C value to the focus. The focus point is at 6, -4. So to the right 6 and down 4. So I'm going to put F for my focus point. That's at +6, -4. An eccentricity of 4/3. Well, where are we going to start in this one? If I know that my center is at -2, -4, and my focus is at 6, -4, one thing that I know about this hyperbola is that it wraps around that focus point, right? So I don't know the A or the B, but I know that a hyperbola is going to always wrap around that focus point. That's how that was created in the first place. So there's one branch of my hyperbola, and then the other branch is going to be off to the side of our paper here. And so if this is my center, here's my focus. I do know that the distance from the center to the focus is a distance of C. So from -2, -4 to 6, -4, looks like I have a C value of 8. All right, well, my C value is 8, but C's not in my equation. I really just need to know the A and the B. Well, what was the eccentricity again? Eccentricity of this equation was always the C value divided by the A value. C divided by A. But take just a quick second. Wait a second. We said that the A value, we said that the C value was 8. But this says C is 4. So the one thing that I want to point out to you using this equation is that this eccentricity could have been a simplified value. Same thing happens if they tell you the slope with the A over B or the B over A. It could be a simplified fraction. And so if C is actually equal to 8, that means that the A value looks like that's going to be equal to 6. So now I know that C is 8, that A is 6, and that's going to help me find my B squared value because I know that A squared plus B squared equals C squared. So my A squared is 36, my B squared is what I'm trying to find, my C squared is 64. That leaves me with B squared being equal to 28. And really, I don't even need to write down just plain B because remember when I'm writing the equation, I've got A squared and B squared there. I don't need to worry about the rest of that. All right, so now we're trying to write the whole equation of this whole thing, and I think we are about ready to do that. I know that it's wrapping around in the x-axis direction, so I know that the x squared is going to be what's positive up here. I know that my center is at -2, -4. So if I'm going to write the equation, I'm going to switch to red here. I'm going to end up with x plus 2 squared. The A squared value is going to give me 36 minus y plus 4 squared. That b squared value we found to be 28. And the whole entire equation is going to be set equal to 1. And now you are ready to try your book problems from section 8.3.